In this video, I'll be explaining question 2 of homework 5. So we are given f of xy is equal to 1 upon a y square x, where y is greater than equal to 1 and x is between 1 by y and y. And we need to solve the following 4 parts. So starting off with the first part, we need to draw the non-zero definition region for f of x and y. So when we try to plot the graph, we can see that this line represents x equals to 1 by y and this represents x equal to y. So, and we are also given that y is greater than equal to 1. Basically, this is y equals to 1 line and y should be above this line, and x is between 1 by y and y. So 1 by y is represented by this curve and y is represented by this line. So x lies between this region and y lies above it. So the shaded region basically represents the non-zero definition region for f of x, y. For the second part, we need to find a so that f of x, y is a valid joint density function. So for a valid joint density function, we know that the integral over x and y for f of xy should be equal to 1. And if we see the limits of integral for x will be from 1 by y to y, and for y it will be from 1 to infinity because y is greater than equal to 1. And once we try to solve the integral, we can see that a will come out to be equal to 2. Now for the third part, we need to find and draw the marginal density functions f of x and f of y. So for marginal density, we integrate the joint probability density function over the other variable. So if we need to find the marginal density function f of x, then we'll integrate over the joint probability PDF over y, which is the other variable. So f of x will be equal to integral of f of xy dy over minus infinity to infinity. And from the graph, we know that for the region x between 0 to 1, which is basically this region, so the value of y is from 1 by y to infinity. So sorry, it is from 1 by x to infinity. Y will range from 1 by x to infinity because y here this curve represents y equal to 1 by x, so the value will be from 1 by x to infinity. And we'll integrate and find that this will be equal to 1 by 2. Now for x from 1 to infinity, which is so x equals to 1 is this line, and from x 1 to infinity the value of y will be from x to infinity. So we'll integrate over x to the limits for y will be from x to infinity, and on integrating it will be 1 by 2x square. Now when we plot the graph for this, we can see from x 0 to 1 it is 1 by 2, and for x greater than 1 and less, basically x greater than 1, it is 1 by 2x square, which is represented by this curve. Now similarly, to find f of y, we will integrate f of xy over x from minus infinity to infinity. And so for x we know that the limits range from 1 by x to y, so we will put the limits from 1 by y to y, and once we integrate, we find that so this will be equal to ln y by y square when y is from 1 to infinity, and it will be 0 in other cases. This is because when y is from 1 to infinity, we see that x ranges from 1 by y to y, and for other cases it will be f of y will be 0. When we plot this, we can see that the curve will look somewhat like this. Now for the fourth part, we need to verify fx and fy are valid density functions. So basically, to prove that these are valid density function, we'll integrate over minus infinity to infinity, and that should sum up to 1. So first we are integrating f of y, which is ln y by y square dy over minus infinity to infinity, and since we know that this is valid for y greater than equal to 1, we can put the limits as 1 to infinity. Now we know that 1 by y equals to x as given in the line, and when we take the uh, derivative of on both the sides, we will get ln y dy equals to du. So sorry, 1 by y equals to u, this is an assumption that we are making, and so when we take the derivative on both the sides, we'll get ln y dy equals to du. This is just so that we can easily calculate the integral. So now this can be represented by du upon u square, and this is the integral that we can calculate using the formula. So the integral will be u of minus 2 plus 1 upon minus 1 from 1 to infinity, and that will be 1. So since it sums up to 1, we can say that f of y is a valid density function. Now similarly for f of x, we need to prove the same. We know that fx equals to half from x between 0 to 1, and 1 by 2x square when x is greater than 1. So when x is between 0 to 1, it is half, so when we take the integral of half from 0 to 1, we get as 1 by 2, and when we take integral of 1 by 2x square from 1 to infinity, we can see that on integrating we get it as 1 by 2, which actually will sum up to 1. So from this we can say that fx is a valid density function.